In this video, we're going to start talking about patterns of growth. So how we decide how fast things are growing, how we can predict future values, um, and use those ideas in applications. And so we're going to start off with the idea of linear growth. And again, hopefully a lot of this is things that you've seen before, but probably phrased in kind of a different way. So, what we want to do in this class is not so much just talk about what is a linear equation, this is how you solve a linear equation, this is the slope, this is the y-intercept, this is how you graph it, all that kind of stuff that you've probably seen before, but we want to talk about the applications. What does it mean that something grows linearly? How is that different from how something grows when it grows exponentially, which we'll talk about next? And then what are some of the applications? Okay, so let's just talk about an example. So let's say that you write an app for a phone or something. Your new app has 1,200 users and is adding 35 users every day. Okay? And say you want to know how many users will you have in a week or in a month or in a year or something like that if this pattern continues to hold. Okay? So there are a couple different ways that you can approach this problem. So say, it's not a question, that's a statement. Say you want to know how many users you will have in a week. Well, you can work from this kind of very logically, right? So basically, you know how many you have on day 0. You have 1,200 users when you start off. On day 1, you're going to have 35 more. So 1,235. On day 2, another 35. So 1,270. On day 3, another 35. So 1,305. On day 4, another 35, so 1,340. And you can continue this pattern out to day 7, which would be a week away, and see very easily 1410 that after 7 days you would have 1,445 users. Now notice that we start with our initial value on day 0, right? That's today. A week would be 7 days after that, which is day 7. So just be careful with your counting and things like that. Okay? So this is one approach that you could take. You would get your answer. So this does solve the problem. But you can imagine that if you were trying to figure out the number of users in a month or in a year, this maybe would not be the right approach to take, right? So, because if you wanted to do this for a year, you would have to add 35 on over and over and over and over again, okay? So, the other approach that you can take that you can see here kind of immediately from this kind of approach that we're taking here, well, you also could have said, okay, we're starting at 1,200. We add 35 each day for 7 days, right? So we add 7 times 35, which would be 235, or 245, which equals 245. So 1,200 plus 245 equals 1,445. Same answer, okay? So these two different approaches to solving the problem, we're going to talk about both. The first one is called a recursive equation. And the second one is called an explicit equation. Okay? Notice you can use either of them to get your answer in this particular case. In other cases, one of them is going to be better than the others. Okay, so we'll talk about some other kinds of problems that we can solve this way. But we're going to talk about both the recursive equation and the explicit equation. Okay? What I want to talk about first, before I dive into that particular aspect of this, is what it means that this is growing linearly. Okay? So we say in this situation that the number of users grows linearly. And let me give you the definition of that. So the number of users grows linearly. And for those of you who remember some of your algebra material, if you graph this, this means that if you graph the number of users, the graph would be a straight line. Okay, so that's why it's linearly. Okay, so the number of users grows linearly. What that means is that we add or possibly subtract a constant number for every unit of time. Okay, so each day we're adding on 35 users. That number never changes, right? It's not 35 one day, 40 the next, 45 the day after that. It's always 35. Okay, so this 35, you'll remember from the last section, is called the absolute change is constant each time. Okay, so if you remember from the first section on percentages and rates, the absolute change is the actual number that we change by each time. Okay, so that absolute change never changes. Okay, as opposed to the relative change, which was the percentage change, that does change. So 35 is a different percent each time, but it's always the same number. It's always the same absolute change. Okay, so that's what characterizes linear growth. So if we're in a situation where we're adding the same number on every single time, we're going to call that linear. Or it's if we're subtracting the same amount each time. So if you had a situation where you have, say, $10,000 in a bank account, and spend, say, $200 each week, the amount of money that you have in your bank account is going to decrease linearly. Some mathematicians would say that it grows in a negative direction. That's kind of confusing language, but it would decrease linearly by the same amount every single time. Okay, so we would have 10,000 one week. Then the next week we would have 10,000 minus 200, 9,800. Then the next week 9,600, 9,400. It would be changing linearly. Okay, so that's what characterizes linear growth. In our next video, we'll talk about how to solve problems using linear growth. We'll talk about the recursive equation and the explicit equation and how we can use each of those.